Okay, so we're going to be talking about absolute value functions today, at least the first part of them. We have three different learning goals. The first is that we can describe the changes of the values of A, H, and K have on the absolute value parent graph. We also need to be able to graph absolute value functions when we're given an equation. And then we need to be able to determine which parts of an absolute value function are reasonable for a given real-life situation. So first we should probably define an absolute value function, which it is a type of piecewise function, which is why we're studying it right after piecewise functions. It consists of two rays, is V-shaped, and has a corner point called a vertex. So most of you probably know what an absolute value graph looks like because you did graph them in Algebra 1, but you didn't talk about the parent graph. Parent graph is a term that we are going to be using probably for the rest of your math career, but definitely in Algebra 2 and pre-calculus for sure. The parent graph means basically the simplest version of that type of equation. So for the absolute value graph, the simplest absolute value graph that you could have is y equals the absolute value of x right here. And here is what this graph looks like. It has a vertex at the origin. It has slopes on its rays of 1 and -1. So the reason why this is the simplest is because there's no added or subtracted or multiplied numbers to go with that equation. When we are looking at different types of equations, and we're going to learn lots of parent graphs this year, you have the parent graph, the simplest, and then you have the general form. This is the general form right here. Y equals A times the absolute value of x minus h plus k. Now, in order to be able to meet the first learning goal, to describe the changes that these are going to have, we need to be able to. So h and k, which you can see where those locations are, one of them is inside the absolute value, one of them is on the outside. Those values are going to tell you where the vertex is, which means from the parent graph, that's going to shift your graph. It's going to shift it left, right, up, down. So h is the x value. So that means that h controls your left or right shift. K is the y coordinate of the vertex, so that is going to control your up or down shift. The axis of symmetry is always through the x coordinate of the vertex. Now, we know that it's always going to be V-shaped. However, sometimes the V goes up and sometimes the V goes down. The way that you know is by the sign on A, the number in front of the absolute value. If A is greater than 0, meaning that A is positive, it's going to open up. It's going to open down if A is less than 0, meaning if A is negative. Now, we also need to know what the effect of the value of A is going to be. So we know what the positive or negative part does, but we need to know what the value does because there's a difference between having a 5 out here and having a 2 out here. What those values do is what I have next. The graph is going to be wider if the absolute value of A is less than 1. That basically means that if the value of A is a fraction or decimal that is less than 1. So not a fraction like 3/2 because that's bigger than 1. That's 1.5. So something that is not 1, between 0 and 1, if it's a fraction, it's going to make your graph wider. It's going to make it fatter. The graph is going to be narrower if your A value, again, we're not looking at the sign, we're just looking at the number itself. If that number itself is an integer that's bigger than 1, so if you have 2, 3, 4, 5, so on and so forth, those are whole numbers or fractions that are bigger than 1, then the graph is going to be narrower or skinnier. Your actual values of A represent the slope of the rays, which is why it controls the fat or the skinny. So let's take a look at our examples. The directions say describe how to obtain the function's graph from the graph of y equals x. Then graph the function and identify the vertex. So please, 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 it's so important to read the directions. I always get people here who all they do is graph the function because they don't read the directions, they see the equation, they put it on the graph, and they think they're done. Notice it says describe how to obtain, because parent graph work is really important. You have to be able to look at that equation and say, how am I going to move things around? It also asks you to identify the vertex. So we need to do both of those things. So when I look at this equation, I've got a whole bunch of stuff going on. So I'm going to look at this, and I know from what I just went through up here that A is going to control whether it goes up or down and the slope of the rays. So I know that since this is negative, that means it's going to open down. So you can either say open down, or you can say the proper geometric transformation is that you're reflecting it in the x-axis, which is the same as saying it's going to open down. And that is because this was negative. Now, there is no number with the negative, which means that the number there was 1. So -1 was the value of A, which means that when I'm describing how it's going to go, it's going to have the same width because it's narrower if it's bigger than 1, it's wider if it's less than 1. This is 1. So it's going to have the same width as the parent graph, which means that the slopes of my rays are going to be 1 and -1. So all of that I get just from my A. Now I move on here. What's inside the absolute values controls my left-right shift right up here. So it's the opposite of what you might think. When you have a negative on the inside, that means you're going to move to the right. So you are going to shift right 1. On the outside, that it's going to keep its sign. It does what you think. A plus goes up, a minus would go down. So +1 on the outside, that's my K that controls my up down. So that means I'm also going to shift up 1. Now, a way to remember which one you change the direction and which one you keep is to think of it this way. These are absolute value bars. If you have your ex in the bar, your ex-boyfriend or ex-girlfriend, you're probably going to want to turn around and go the opposite way. So if you see your ex in the bars, you're going to do the opposite. If your ex is out of the bar with you, then you don't care. You don't need to turn around. It can stay the way that it is. So X in the bars, you've got to change it. X out of the bars is fine with you. It stays with how it is. So shift right 1 and up 1, which means that the vertex, because that's the other thing it asked, is to list the vertex. So if the parent graph's vertex is at 0, 0, and I shifted right 1, up 1, that means my vertex is at 1, 1. So now I just need to put all that information into my graph. So a vertex at 1, 1 is here. The slopes of my rays are 1 and -1, and I know it opens down. So down 1, right 1, down 1, right 1, down 1, right 1, until you get off the page. There's my ray that has a slope of -1. My other ray has a slope of +1, so down 1, left 1, and continue the pattern. So that is what your absolute value graph should look like. So I've answered all parts of the question. I described how to obtain it. I reflect it in the x-axis, which means I make it open down. I keep it the same width as the parent graph, which means the slopes of my rays are 1 and -1. I shifted my vertex to the right 1 and up 1, which means my vertex is at 1, 1. All right, the more you do of these, this should be easier than the piecewise functions. So hopefully you'll get the hang of it after these 4. So I'm going to look at it and I'm going to say this too, it's positive, so I don't need to reflect because I know that that means that this opens up. So the 2 is an A value bigger than 1, which means if you look up here that this one is going to be narrower than the parent graph. The other one was the same width. And the specifics means the slopes of your rays are going to be 2 and -2. So it's always the A value and its opposite. Then this value, it's inside the bars. When you see your X in the bar, you do the opposite. So that means I'm going to move to the left 2, which means that my vertex is at -2 for the X coordinate. Over here, I'm outside of the bar, so it can stay the same. So minus means go down, down 3. So my vertex is at -2, -3. So if I want to graph this, I go left 2 and down 3. There we go. It's going to open up, we said, since the A was positive. So from this point, I'm going to go up 2, right 1, up 2, right 1 to make it open up, as well as up 2, left 1, up 2, left 1. So those rays, one of them, this one right here, has a slope of 2. This one right here has a slope of -2. All right, let's continue. A little bit more practice. Here, I've got a 2/3 there. 2/3 is a fraction. Again, on fractions, check to make sure it's a fraction actually smaller than 1, which this one is, which means when I have a value where it is smaller than 1, A is a fraction, it's going to be a wider graph. So this is wider than the parent graph, so it's going to be a fatter V. The slopes specifically are always A, which is 2/3, and its opposite, -2/3. Then, after I've described that, I need to describe what's happening here. I know that this one opens up because it's positive. So this, X inside the bars, do the opposite. So you would think that if you were just looking at it, you would think left, but we're doing the opposite, so we're going to shift right. So shift right 4, which means your X coordinate of the vertex is at +4. And this means we're going to shift up 9. So 9 is the Y coordinate of my vertex. Now, never ever plot until you know where your vertex is and which way it opens, because here, everything I've done so far, I've counted by ones. Here I can't because +9 is way up. So I need to count by something different. I need to use a different scale. If I use 2s, 2, 4, 6, 8, 10, I can get it on there, but this one opens up. So I'd be trying to squish to get it in. I'm going to count by 3s because I know that that's going to give me plenty of space. So if I'm counting by 3s, when I plot this vertex at 4, 9, to go right 4 means go right 1 unit and then a little bit more to get the 4, and then up 9 would be 3, 6, 9. So if you're counting by threes, your vertex goes right there. Now, from the vertex, I know it's going to open up. I look at my slopes, 2/3, so that means up 2 and right 3. 1, 2, 3. Again, these are not going to be on exact dots because your vertex wasn't on an exact dot. Then over here, to get the negative 2/3 slope, you go up 2 and to the left 3. 1, 2, 3. And then you can connect, and you've got your lovely V. And it's hard to tell that this is wider just because of the counting by threes, but we went up 2 and right 3, so we should be good. Now, you may have noticed and you may have been confused when I counted the up 2, right 3 in actual units. It's because as long as you keep the scale the same, counting up 2 units and right 3 units is going to be the same as actually going up 2 and right 3. If I were actually going up 2 and right 3, up 2 would be less than a whole space. Right 3 would be one entire space, which would be to the middle over here. Then I would do it again, up to right 3. As long as you always use the same X and Y scale, it's going to be equivalent, because what I really did was go up 3, 6 and over 3, 6, 9. But 6 over 9 reduces to 2/3. So just in case you were confused by that, I thought I should explain it. As long as you use the same scale on X and Y, you can do it that way. If you change the scales and make them different, then don't do that because your answer won't look right. All right, last one, I'd like for you to pause it and try it yourself just to kind of see where you are with this, and then unpause to see my solution and make sure that you're on the right track. So the first thing you should have done is look at this A value. So -1/2, that means it's going to open down. So that means I'm reflecting my graph. So this one's going to open down. Because the value of this is a fraction less than 1, that means this one is going to be wider. The slopes of my rays are going to be -1/2 because that's A, and its opposite, which is +1/2. My shifting over here, -1 inside the bars means I'm going to go to the right. So shift right 1. And this -2 means down 2. So that means my vertex, again, X in the bars, you change the sign, go the opposite direction. So opposite would be +1. Outside the bar, they can stay. So 1, -2 is going to be your vertex. If I look here, 1, -2 would be right here. I do have room for it to open down, so I don't need to use an alternative scale there. Here's my vertex. The slopes are 1/2 and -1/2. In order to get it to open down, that means down 1, right 2, down 1, right 2, or down 1, left 2 to get the positive slope. So here's my +1/2 slope. Here's my -1/2 slope. And there is my lovely graph. All right, last example, which meets our last learning goal of determining which parts of an absolute value function are reasonable for real-life equations. It says the front of a roof with its outer edges 8 feet above the ground can be modeled by, and then it gives you this equation, with X and Y in feet. Graph the function Then we want to determine how wide and high is the roof. Now, it didn't ask us to describe anything, so you don't have to write out all of this. At least that part won't be graded if it doesn't ask for it, but you may want to jot some notes down here. You know that that opens down because it was negative. You know that the slopes of the rays are going to be negative 2/3 and 2/3. And you don't have to describe the shifting, but you should probably know where the vertex is. We do the opposite for in the bar, so that's 9. Same for out of the bar, 14. Now again, 9/14 is going to be off your page, so we need to pick an alternative scale. Here I'm going to count by 2s because that should have plenty of room. So to plot the vertex at 9/14, I'm going to go right 2, 4, 6, 8, 9 would be halfway between 8 and 10, and up 14, so 2, 4, 6, 8, 10, 12, 14. So there's the peak of my roof, my vertex. Again, because I used the same scale for X and Y, my 2/3 and negative 2/3, I can really, instead of just trying to confuse myself with the 2s and the 3s, I can literally just go down 2 units, so 1 unit, 2 unit, and right 3 units, so 1, 2, 3 units, 3 spaces. Same thing here, down 2 spaces, left 1, 2, 3 spaces. Now, here is the absolute value function, if we're just graphing the function. But we are talking about a roof, and specifically, it tells you that the outer edges are 8 feet above the ground. 8 feet above the ground, 2, 4, 6, 8. 8 is right here, which means the outer edge should go where that is, which is right here. And if I go across, I kind of connected it not very well. Hopefully you used a straight edge, but it actually goes through here instead of over there. That's why it would be nice to have a straight edge on here. So if your little house was right here, there are the outer edges of your roof. So let's look at what it asked. How wide and high is the roof? So width would be this. How wide is the roof? So you can count. We're counting by 2s. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18 feet wide. How high is it? Well, highest is to the highest point, so there's the peak, and that number was at our vertex y coordinate, which was 14. So 14 feet high. Again, you have to be able to know that the rest of that graph, the arrow, is not reasonable because this is a real life situation. All right, that is it for this lesson.